Hey, thank you for coming. It is always a pleasure to be the last session of a conference before you get done because I'm between you and whatever you're going to do for the rest of the evening. Hey, my name is Ravi Kupuswamy. Okay, I actually run the server product and engineering teams for Epic. Essentially responsible for putting the Epic products on our roadmap and then carrying it forward and delivering to customers. Today, what I'm going to do is I'm actually Nav here was supposed to be my co-presenter, but he had an urgent thing to go to, but he's recorded it in terms of what he wants to say about the Uber success story based off of Epic. So, we're going to hear from Nav after I finish presenting here. What I'll be speaking to is actually the challenges of deploying enterprise AI and what it is from an inference standpoint, what does it mean from a training standpoint, and how do AMD products help alleviate that? Specifically the Epic product line, how does it alleviate those concerns? And then showcase, at the end of this is where they're going to showcase how has Uber used it. How have they solved it in real life for their applications? And then that's a great proof point for somebody who's been using it at scale. So let me start by saying, as you guys know, AI is transforming things at an amazing pace, okay? We've used it in all aspects of ours, whether you want to optimize business processes, and in some of the things that you guys feel very mundane, contracts and inventory management and pricing and so on and so forth, versus if you want to go to accelerate innovation, where specifically from a drug discovery standpoint or material science development and what we need to go do in several aspects of our business, AI can accelerate human work, especially knowledge workers, and augment our workforce, and it's exploding with the kind of things that we can be doing with AI is just limitless. The possibilities are amazing, but we need to garner it to go solve real world solutions. And how do you do it in a fashion that gets you that benefit is what I'm going to talk to you about. Today's AI workloads can be classified into 5 buckets. And in some of these, you've seen in the evolution of stuff, the traditional machine learning, the very old AI in some sense, is related to decision trees and linear regressions, recommendation systems that are still used today. Language models and generative AI is what I think most people feel is most prevalent, leading to natural language processing. And what I'm particularly extremely excited about is mixed AI-enabled workloads. Those are both different and unique to enterprise. These workloads capture that AI that is embedded into traditional or established AI workloads. As we move forward, these boundaries are going to blur in many fashion. Today morning you must have heard Lisa speak about agentic AI and the whole fact about how there is a left corner and a right corner, and how agentic AI is actually prevalent across both from the left spectrum all the way to the right. And they use different types of models, and orchestrating those workloads across this entire spectrum using the right type of compute, the right software structure for these mixed workloads is super important. So this is pictorially what we're talking about, where you have on the left-hand side of this is our GPUs that deal with performance, deal with scale. To the right side is our CPUs, which optimize for the power and cost of what we need to be doing in this agentic AI spectrum. And the crux of building something like this is that AMD offers both powerhouse GPUs and leadership CPUs to cover the span of all the enterprise needs that there may be, all supported through our open ecosystem. Agents in general will leverage high-performance GPUs where required to run large language AI workloads and require highly efficient CPUs where you have more rudimentary models that can be run with smaller parameter sizes so that you get the best perf per TCO for your business. And enterprises come in different shapes and sizes, and there'll be ones that requires to span this entire spectrum of agentic AI. Fortunately, what we're really saying here is, even in a case where you are using a GPU to run large language models, you need a highly efficient CPU, a powerful host processor for any AI accelerator. Why? Because there are this pre and post-processing tasks, orchestration, scheduling, synchronization, launches of our kernel, etc., which needs to be done with a really high-performance CPU. For a showcase today, the 5 gigahertz Turin, which is our 5th generation EPYC processor, which is essentially purpose-built to go play this host processor socket. And it's truly a leadership in all the tasks that we just talked about. And by using an x86 platform, you have not only gotten a broad ecosystem of the software that can actually run on top of it, but also EPYC provides the flexibility to host the AI and any other workloads you need on the same system. You know, as you hear Uber talk to you about it, they will tell you how they utilize or maximize the utilization of their CPUs by actually running general purpose compute during daytime and then queue up all of the pre-processing that they need to go do on the CPU over nighttime, thereby maximizing the efficiency of their entire fleet. In addition to seamlessly supporting the backbone of enterprise software, we also use our high-performance CPUs to drive agentic AI. AMD EPYC leads up with 64 cores, runs it to 5 gigahertz in operation, okay? And it is robust enterprise class workloads that can be run with EPYC. So if you were to take away, there are 3 things that we wanted to do in this space. You're leveraging the x86 ecosystem. It is highest performance with the highest frequency. And it has robust enterprise class RAS, reliability and serviceability in this space. Now let me walk you through what does it take and the performance benefit of EPYC as a great host processor. There are at least 3 specific workloads here where you see anywhere from 7% all the way to 13% across a wide range of workloads that are there. And here we have just compared this where we've used the same GPU while we've connected it once to a Xeon and the other to an EPYC. And you see anywhere from, like I said, 7 to 13%. The performance boost in every one of these cases can be directly correlated to what you can achieve in terms of the total footprint that you have for your accelerator. So thereby, a great CPU here can be used to go modulate your footprint, thereby saving whether it be power or area that is required for your entire acceleration ecosystem. So for example, let me take the example of Mixtral. in the case of Mixtral X87B, which is a mixture of expert models, which requires CPU to be involved in coordinating the data flow through the model and to the particular experts, this becomes a very heavy CPU workload and showcases the benefits of higher performance CPUs. So in real life, we are expecting a wide range of such applications, and even using a CPU as a host processor gives you great benefit for the overall infrastructure. Now, CPUs clearly are an integral part. Now, let's start taking a look where you start seeing the CPU as an inference engine itself directly, as opposed to as being a host processor, where the power and the cost elements of it come into play. Enterprise is a wide category and covers companies big and large. Several of them have constraints, and regardless of these sizes, enterprise often have common pain points. Power constraints, cooling complexity, consideration for capital expenses, and operating expenses of them being on-prem or on the cloud. And all of these challenges essentially create cost and complexity. And enterprises have unique challenges of off-peak resources and inconsistent data center workloads. And you have to deal with all of this together. Now, what we're going to do is we're going to see how does EPYC address each of these different pain points specifically as seen by these enterprises. These two benchmarks show a machine learning workload, okay? XGBoost, where you will also hear from Nav, where he'll mention this later and how he uses it, in which recommendation system algorithms finding items of similarity to user preferences or need. In every one of these cases, you have seen utilizing EPYC gives you a substantial improvement over Xeon because of the fact that we fundamentally have built this microarchitecture from the ground up. The next set of examples are for generative workloads. Okay, these models were small to moderate size. They can easily run on a CPU such as EPYC. And here, again, we have shown whether it be a Llama model or a GPT-J model, in each of these two cases, you have a 33% improvement to 28%. Again, key value vectors that enterprises care about and can be run at lower cost and much more power efficient. Finally, for our natural language workloads, we are seeing EPYC handily outperforms the latest generation competition. A large part of it is, in this case, is particularly true because of the larger core count that EPYC has. Translation, essaying, summarization, anywhere from 20 to 36%. We're seeing EPYC do better. While this is not a benchmark itself, for those folks who have walked down to our demo halls, you will also see that this is a representative of a mixed workload running common telecom operations along with AI. And this is one of many demos where we are showcasing EPYC as a foremost processor that you can use great for general compute and efficiently use it for AI workloads when your general compute utilization is lower. So let me try and bring this all together, okay? We are trying, AMD is driving EPYC adoption for AI inference, helping customers across accessibility, utilization, locality, and memory. And I'll just quickly walk you through this. It's not just about performance. It's about the fact that CPUs are present in most of these places already. We talked about cases where utilization is lower for different enterprises at different points in time, and how CPUs can meet that need, given they are already there in the data center. Locality in mixed workloads, and in cases where the latencies are much smaller, given the fact that they're already interwoven in the heart of the data center. And then it already has large memory capacity for weights to run multiple language models that need to be run. So on top of performance, on top of the fact that it is more cost efficient and more power efficient, these are additional advantages that AMD EPYC processors bring to a broad class of enterprise workloads. So AMD EPYC processors have truly been built for low power, low cost AI inference. Fast inference for increased workload capacity, easy integration of it across the board, and then add AI workloads without adding power. So with that, what I'm going to do is we're going to run a video where you're going to hear the Uber story directly from Nav. Unfortunately, he couldn't be here because of a health issue, but he did say, he's gone ahead and taken the time to record this for us. And he's going to walk you through why did they strategically select AMD EPYC on multi-cloud as their infrastructure of choice. Click it forward.
Thank you, Ravi. Now let's explore how Uber is partnering with AMD to meet our infrastructure needs. Currently, Uber handles 33 million trips daily, serving 170 million monthly active users. People depend on Uber services on a daily basis, whether it is to go to work, get food or grocery, or to even earn a living. This demands a robust technology stack to ensure our platform consistently delivers the highest quality of service that our users expect. And at Uber's scale of millions of cores, there are various layers of infrastructure stack that needs to be orchestrated across both on-prem and cloud environments. Next, we will see the diagram on the left side that illustrates Uber's infrastructure stack that supports diverse workloads such as stateless services, databases, batch processing, and machine learning. These workloads are managed by shared fleet fabric that groups services by placement classes, enabling collocation and centralized buffer management. Our strong synergy with cloud partners and CPU vendors like AMD ensures reliable, scalable operations for us. Continuous tuning, cloud elasticity, and proactive resolution of issues enables efficient scaling of our infrastructure. Next, we'll look briefly at the Uber's cloud migration journey. So we began our cloud migration journey with GCP and OCI in late 2022, and that was focused on accelerating innovation and optimizing costs. And I'm happy to report that our trip serving stack on OCI and batch and ML stack on GCP has now migrated across multiple zones, marking a significant milestone in our migration journey, providing valuable insights along the way. When selecting a VM shape in any cloud, we follow three basic guidelines. The first is to meet the business goal, such as efficiency measured by metrics like dollar per core or perf per dollar. Second is we try to match workloads to appropriate shapes. For example, we use the flexible shapes provided by cloud vendors to optimize the resource ratios for running batch jobs or machine learning models on AMD's EPYC CPU chips. Finally, we collaborate with AMD to leverage next-gen technologies like PCI 6, DDR5, CXL, ensuring our platform is future-ready. And this is just the beginning of a multi-year cloud migration journey, eventually moving more and more workloads to AMD CPUs in the multi-cloud environment. Next, we're going to look at some of the learnings and takeaways from OCI's E4 and E5 shapes, which are like AMD's SKUs in the Uber infrastructure. And many such issues were resolved through close collaboration, underscoring the importance of early collaboration with AMD and OCI. We have a metric called performance improvement factor that we track, which is focused on extracting highest performance from each SKU that we have. For Presto, adopting VLOX enabled vectorized execution that better utilized AMD's compute and cache hierarchy, yielding strong gains without requiring workload changes, and hence improving PIF. We are excited about GCP's C4D shapes that are based on Turin's architecture. We expect over 30% better spec JBB per dollar compared to C3D. And as far as ML, not all ML workloads need GPUs. XGBoost, for example, runs well on CPUs today. Some of the deep learning workloads run well on AMD CPUs. C4D provides predictable performance for such workloads. And our early involvement and benchmarking of C4D resource and requirement and resource planning ensures that we are tuned for our requirements from day one. So to conclude, this collaboration between AMD and our cloud partners and Uber has been instrumental in driving performance, efficiency, and innovation technology trends across the stack. It's a strong example of what's possible when partners work closely together. And we are looking forward to this wonderful partnership and adopting more workloads on AMD's EPYC CPUs. With that, over to Ravi. Thank you.
Thank you. Hey guys, as you can see, just maybe I'll just add a couple of lines to what Nav's trying to say, right? Here is a prolific user whose demands are very, very high. Classic case of where they have both general compute and AI compute needs. And you can see that they completely run on AMD EPYC CPUs. And he talked to you about how they build the stack, how they utilize it, and how we're collaborating with them, not just in the current generation, but also in the future ones, to essentially meet Uber's needs. Thank you. Thanks for your attention.